Question 15. This is a question about bounds. Bounds and accuracy. So, we're told the length of a side of a square is 6.81 centimeters to 3 significant figures. Work out the lower bound for the perimeter of a square. Here's the method I use for looking at what the bound is. 6.81 to 3 significant figures. What would be the next highest value to 3 significant figures? It would be 6.82. What would the next lowest value be? It would be 6.80. The upper and lower bound for 6.81 is going to be halfway between that value and the ones either side. So the upper bound is halfway between that and 6.82. It's 6.815. The lower bound is halfway between these two. It's going to be 6.805. We only want the lower bound at this stage. But the upper bound is important for the next part of the question. Oh, whoops. I've forgotten. It's the perimeter of the square we want, not the individual sides. So we need to times that by 4. And we get 27.22. Now, it says give the perimeter of the square to an appropriate degree of accuracy. We know that the lower bound for the perimeter of the square is the answer we just calculated, 27.22. If we want to work out the excuse me, the upper bound, lower bound is 27.22. The upper bound is going to be 4 times the longest possible side of the square, which is 6.815. So 27.26. Now, to write this to an appropriate degree of accuracy, we want it to be to the highest number of significant figures possible. So 4, 5, 6 significant figures, whatever we can get away with. But in order to do that, let's look at the most number of significant figures and see if our answers agree. Well, to 4 significant figures, the lowest possible perimeter of the square is 27.22, and to 4 significant figures, to the highest possible value is 27.26. So 4 significant figures, these two answers are not covered. Okay, let me explain this better. The range of the perimeter is 27.22 to 27.26. So to 4 significant figures, there's no answer that covers that range. To 3 significant figures, this would be 27.2, and this would be 27.3. So again, there's no single answer that covers the range from the lowest possible to the highest possible value. To 2 significant figures, this would be 27, and this would be 27. So that's the highest level of accuracy we can give, for which the lowest possible value and the highest possible value will give the same answer. 27 is therefore our final answer. This is a classic question. You get this in pretty much every paper, or this type of question in every paper, and people do struggle with it. You've got a quadratic on the top for which the coefficient of x squared is not 1, and it's therefore pretty hard to put into brackets. And then you've got this x squared minus 16 on the bottom. In this type of question, you've almost always got one quadratic expression for which the coefficient of x is 1. And that's the one you should factorize first. X squared minus 16 is your standard difference of 2 squares. So, sorry, x squared minus 16 is going to equal x plus 4 times x minus 4. Now, knowing that x squared minus 16 is x plus 4, x minus 4, we can assume, because it's a GCSE maths question, that this will factorize so that one of the factors is either x plus 4 or x minus 4. So we test it out. We say, okay, let's assume that 2x squared minus 3x minus 20 is equal to x plus 4 times something. Now, if it's going to match up, x times this bit is going to have to equal 2x squared. So that would have to be 2x for the x squareds to match up. And for this minus 20 to match up, plus 4 is going to have to multiply by minus 5. Now we see if this matches up with the x's. 4 times 2x gives us 8x. Minus 5 times x gives us minus 5x. That's up to plus 3x. So that doesn't work. So okay. It's not x plus 4 that's a factor. There's a very good chance that x minus 4 is a factor. This x is going to have to multiply by whatever's here to make 2x squared. So that has to be 2x. And to make minus 20, that minus 4 has to multiply by plus 5. Does this match up with minus 3x? Well, we have minus 4 times 2x, which makes minus 8x, and plus 5 times x, which adds 5x, which makes minus 3x in total. So that's what this factorized to. So the whole thing is equal to what we just factorized the top as, and what we already knew the bottom to be. And as you can see, you have x minus 4 on the top and the bottom. They cancel, and you're left with 2x plus 5 on the top, and x plus 4 on the bottom. Those don't cancel. When we say cancelling fractions, what we're doing is dividing the top and the bottom by the same amount. If you have a sum or a difference, i.e. you have terms added or subtracted together, you're not going to be able to divide everything through unless it happens that, say, 2 or x goes into every single term on the top and every single term on the bottom. That's probably a long-winded explanation. The important thing really is to factorize the top and the bottom, i.e. get it into the form where it's something times something over something times something, and then if you see the same thing appearing in the factorized versions, you can just cross them out because you divide the top and bottom by whatever that factor is.